what let me just share the Can you all see the slides? Can you all see the slides, class?
Yes, Doctor.
Yes? Okay, right. So we are going to limit ourselves to ODE. ODE is ordinary differential equation. IVP, initial value problem. BVP, boundary value problem. And PDE. PDE, we are just going to look at the simple ones, solving simple ones through separation of variables. And maybe we look at some of the classification of PDE. Okay, so what is ODE? Okay, so this is what our syllabus for today is. What is ODE? What is the order of ODE? What are linear ODEs? What is a homogeneous ODE? How to solve ODE through separation of variables? And then we look at initial value problems. We look at Euler's method. Okay, Euler's method is sometimes called the first order Runge-Kutta method. Now, the Runge-Kutta method, when you use it without any orders, it will we are actually relating it to the fourth order Runge-Kutta method, but actually it comes in order 1, order 2, order 3, and order 4. We are only going to look at order 1 and order 4. Okay, order 1 is called the Euler's method, and order 4 is what we call in general the Runge-Kutta method. Okay, what those are, we'll be looking into it shortly. Okay, and then we also look at second order differential equation. We look at the general solution of second order differential equation, and then we look at the characteristic polynomial, the boundary value problem, the partial differential equation, and some of the classifications for PDE. Okay, all right, so far so good. I know it can be overwhelming. Like I said, this is enough to be a course on its own, but we try and simplify things so that we can cover them within 1 or 2 hours, the 2 hours that we have here. Okay? All right, can you still see the notes?
Yes, Doctor.
Yes, Doctor.
Okay, so a differential equation, no, a differential equation will be an equation in which you have your dy dx. And if you're looking at dy dx, then you look at dy dx as a function of x. But if you're looking at dv ds, of course, then it would be a function of s. So if you can still see, can you see the whiteboard at all? No, nobody can see the whiteboard.
No, Doctor.
It's still on the screen, Doctor.
Still on the screen. Okay, let me see if I can do something about it. I can't find the switch. Okay, there seems to be something the matter with the okay, never mind. If we can't, then we just have to rely on the notes. Okay, any function in the form of dy dx equals to f of x, or if we look at if we say that a function ds dt, then it should be in the function of can you see my screen? Can you still see my screen?
Yes, doctor.
Yes, doctor. Yes,
Can you
doctor.
see what I'm typing?
Yes.
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 Okay, then it should be, if you have ds dt, it should be a function of what?
T.
T. All right. Or if you look at d, whatever your a's and b's are. Okay, if you look at da d p, for instance, then it should be in the function of
P.
p. Okay, so don't let that confuse you. If we are differentiating with respect to one variable, then your function should be in that variable. All right. Okay, so an equation in this particular manner would be called a differential equation, because you have on one hand your differential, your dy dx, and on the other hand you have a function. And since we are differentiating with respect to x, the function is in x. Okay, so why is it important? It's a very important topic in calculus. And if it's important in calculus, it would be important in engineering, in the sciences. It is important for predictions, for analysis, and as you all know, in AI, we do a lot of prediction, we do a lot of analysis. Okay, we do a lot of modeling. And if you look at medical informatics, which is or AI in AIM, what is AIM? Do you all know what AIM is? Anyone knows what AIM? Hello?
Artificial intelligence machine.
No. Try again. What is an artificial intelligence machine? That would be a robot, isn't it? AIM is actually artificial intelligence in medicine. It is a very strong field, okay? It is a very big research area, and it is one of my research areas. So if you look at AIM, we do a lot of modeling in AIM. Okay, and when you are doing modeling, you can't stay away from equations, and differential equation could be one of those that you look at. Okay, why do we use numerical methods for ODE, for ordinary differential equation? So that we can find the solutions to the ordinary differential equation. And this is, you've looked at numerical integration, right? So this is what you would do in order for you to solve differential equation. Okay, so this is how your differential equation would look like. Your differential equation would only be in one variable. If there is another variable, then or rather it will have derivatives in one variable only. Okay, it may have your y variable. If it's a dy dx, it may have your y variable, but we are differentiating with respect to x. Okay. Now, let's look at the order of differential equation. The order is actually the highest order. Okay, if you look at the first one, du dt, it's only du dt, so it is first order. The second one, 2 ds dt, again only ds dt, so this is still in first order. The third one, dy dx, again this is first order. Now we are talking about the order of the differentiation, yeah, of the differential equation, not the order of anything else. Okay, only look at your differential equation. Okay, now if you look at the second one, it is dtu dv squared. Okay, so dtu dv squared is actually second order. Although you have a du dv on the right, but we take the highest order. We look at the whole equation and we take the highest order. So for this equation, the order is second. Now let's look at another example. Now if you look at this one, again you have d3u on the left side, but on the right side you have du dy. But the highest order is actually 3 because you have d3u with respect to something. Okay, d3u with respect to d2x dt. Okay, so those are actually partial equation. Now if you look at d3y dx cubed, that would be third order as well. And the next one would be in fourth order, d4y dx4. Okay, so the order does not depend on whether you've got ODE or PDE. It does not matter. We are just looking at the differential part. All right? Is that clear? Is that clear?
Yes, doctor.
Okay. All right. Now we are also looking at linear differential equation. Now, linear differential equation can be written in this form. Okay. The a's can be function of x. Okay, the a's can be anything. The a's would most likely be integers, right? But remember they are function of x. Okay, so you can have 3x, 4x, 5x squared, 6x to the power of 3, and so on. Your y's are your differentiation. Now, y to the n does not mean y to the power of n. What it means is it is a differentiation with respect to n. Now, if you look at it, y prime, this is y prime, right? Y prime we know is dy dx, is the first order. So yn means it is a differentiation to the nth order. Okay, so if you have an equation which can be written in this way, they are all function of x. Okay, this is called a linear differential equation. Okay, let me show you. Now, like I said, the coefficients a naught x, a and x until a and x, they can be 0. If they're 0, that means some of it will be gone, or they can be non-zero. They can be constant or non-constant. They can be linear or non-linear. Only the function of yx is used to determine if the differential equation is linear. Okay, if a differential equation cannot be written in the form that we have written above, then it is called a non-linear function. Okay, if you look at some examples here, do you know why the first example is non-linear? Anyone wants to try? Don't worry about all the others. Just look at the first example. Why is this non-linear? Nobody knows?
Is it because there is a sin y with the d2y
It's
over
not
dx
sin, okay? It's sine.
sine?
Mm.
Is it this because the sine y
Yes.
with the d2y dx?
A sine function is not a linear
Linear.
function, is it?
Yes,
Mm.
it's a circular.
Yeah, it's what do you call it? A wave function.
Yes.
Remember we did Fourier transform last year? Okay, sine function is a wave function, so it's not a linear function. What else? There are three reasons actually, if you look at it. This part here is linear, isn't it? 1 minus y.
We have y square. Oh,
We have
sorry.
y
Yeah,
squared.
y.
Yes, y squared is a quadratic function. So that's not linear. And then what else do we have?
We have e also, which is different. What's it? Which vector function?
Exponential.
Exponential. Yeah, exponential.
Yeah, an
Exponential, yes.
exponential function. Okay? Right? Everyone agrees? Okay. Right. So you can look at the other examples on your own, okay? Now, I'm going to show you a homogeneous function. Okay. Okay, a function, can you see this? Can you see the slide? Can you see the slide?
Yes, doctor.
Yes,
A
doctor.
function with respect to dy and which is equal to gxy with respect to dx. If you can write your differential equation in this form, then it is called a homogeneous ordinary differential equation, or in the simplest form. Okay, in its simplest form, you can write dy dx equals to a function of x and y. Then this is called a homogeneous function. Okay, now with homogeneous function, the beauty of it is that you can put your x in one side and your y's on the other side. And if you do that, okay, if you can put dy with respect to y, and then you bring your dx to the other side, you can put fx with respect to dx. What do we get?
Gy to the respect of y. gy gy to the respect of dy.
gy, well, maybe a big gy maybe, okay? And then you have f with respect to dx with respect to px, let's say, because these g's and p's and whatever, they are just used as notation. They can be anything, right? They just use in the form of notation. So when we do that, you've got your y's on one side and your x on one side. And then what we can do with that is we can solve these equations in a way which is known as the separation of variable. So that would be the easiest way we would solve an ordinary differential equation. Have you all ever done separation of variables before?
Is it like making one variable in the left side and the other variable to the right side? So it's the common thing.
Yes, you bring one variable to one side and another variable to the other side.
Yeah.
Okay. Hello?
Yes, doctor. We can
Okay.
hear.
Trying to change uh, okay. Let me see if I can change the settings. No, I seem to be having problems with the settings. Okay, it doesn't matter. Okay, right. Okay, let's look at some examples now. Okay. If we can rearrange our ODE into this way, okay, we put dy with respect to gy and fx with respect to dx, then we can use separation of variable. Okay, what is separation of variable? Okay, example, dy dx equals to 5. So how would you solve this? How would you solve this? What would you do? Hello? Can you all hear me?
Yes, doctor.
Okay. Can you see the example that in the notes? Example 1. Can you all see example 1?
Yes, doctor.
Okay. What would we do with a situation like this?
Integrate.
Hmm? So what do? You have dy over dx equals to 5. Okay. Can you see what I'm typing?
Yes, doctor.
Okay,
Yes,
so what do we do? You want to integrate this, right? You want to solve this. First step,
So first step, we get the y value first.
dy equals
5dx.
5 dx, yes. And then what do we do?
Integrate both sides.
We integrate both sides and what do we get? Integrate both sides, what do we get? Come on, it's in your notes. Oh, by the way, have you all signed your attendance? I put the attendance link already, right? Okay, dy equals 5 dx, and then what? You integrate both sides, what do you get? You integrate dy, what do you get?
Okay, y.
You integrate 5 dx, what do you get?
5 dx. We get
5x.
Hello? 5x, yes. But don't forget, this is integration, so you must have plus c, right?
C.
Yeah? 5 plus c. Can you see that? Can you see the box?
Yes, doctor.
Okay. Okay, coming back to the attendance, have you all got the link to the attendance? To this attendance? Yes, no? Okay, let me see if I can find the attendance. You want me to remove the background image? Why? Why do you want me to remove the background image? Okay, I will remove the background image because I was using it for another meeting just now. No, I can't find. Okay, give me a minute. I'll stop this. Okay. Mm. All right. Okay, I've removed the background. Why did you want me to remove the background? Oh, so you can see the whiteboard. All right, okay. That was the reason. There's another question here. Why is the second example non-linear? Where is the second example? Okay, let's see. Where is the second example? I think there is something missing in the second example. It is.
Is it
There's probably
because
something
y
missing.
d2y over dx?
There's probably something missing in the second example. Okay. All right. Okay. Okay. Right. So now we are going to use. Let me give you another example. The example is dy dx equals to cosine x. Can you all solve this? What do you get? Anyone has tried this? Anyone tried that?
Doctor, can we see the question again?
You want to see the question again? Okay, this is the question. Can you see that?
Y equals to sine x plus c.
Sine x or minus sine x?
Sine x cos, yeah, sine x.
Sine x. Right. Okay. When you integrate cosine, you get sine x. But when you differentiate cosine, you get minus sine. Okay. Please don't get this mixed up. Okay. And there are other examples here which we will not go into. Some of it could be you may have to do substitution and so on. You may have to use all the laws of integration that you have studied in the past. Okay, so we will not look into all the examples. Okay, now I want to go into something else. Okay, I want to look at what we call initial value problem. Now, an initial value problem, or IVP, is when, when we solve integration, we get something plus C, right? Okay? Do you all agree?
Yes.
Yes.
Okay, now, if you have some conditions that are given to you, you might be able to determine what that C is. Okay, so with the initial condition, you have a nicer solution. Okay, this is your first order differential equation, dy dx equals to the function of x and y. And then you might have an initial value in the form of ya equals to b. Now we use this to help us solve our equation. Okay, this is what we would call an IVP, or an initial value problem. Okay, here is an example. dy dx equals to 10 minus x, y naught equals to 1. Okay, if we solve this, what would we get? Solving this, what will we get? Okay, dy dx equals 10. 10 minus what? 10 minus x. 10 minus x. Okay, so if we want to use symbol, we would say dy in 10 minus x, right? We get y equals to
10x minus
10x minus
x of 2 divided by 2
x squared over 2. Don't forget you have plus c.
plus c.
But you are told that y naught equals to what?
Negative 1.
Yes, y naught is negative 1. Y naught is negative 1. So given that y naught is negative 1, y naught, which is equal to negative 1, will be 10 into 0 minus 0 plus c. What is c then? What is c?
-1.
So now your solution should be, what should your solution be?
10x minus x power of 2 over 2 plus minus 1.
Minus 1. Okay, so the initial value problem helps us determine the real solution for the ODE. Okay, without solving for C, we would call it the general solution. Okay, if we don't know the value of C, we would call it the general solution. But once we have solved for C, it becomes the real solution of your ODE. Okay, so far so good? Now, with the initial value problem, it would have only one solution. Okay, so the number of equations, sometimes number of conditions that we may need to solve the given differential equation will depend on the order of the equation. Okay, the interval of validity. Now, the interval of validity for an IVP is actually within the largest possible interval in which the solution is valid. Okay? When is the solution valid? Well, as long as we have x naught in that interval, and then that would be the solution. Do you understand what we're saying? The interval of validity for an IVP is the interval in which the solution is valid and it contains x naught. So if we are looking at the earlier example that we have, it would be from anywhere between A and B, but 0 will have to be within that interval. Okay, I've mentioned general solution. So this is what a general solution would look like. Okay, remember I said if we don't know what the value of C is, but we have solved the differential equation, then we get a general solution. But once we know the value of C, we get the actual solution. Okay, we have done this. So this is the general solution, and this is your actual solution. Okay, so far so good? Do you think you can do one more example? Okay, this is another initial value problem. Can you solve this? We solve this and then we can go for a short break. Just a short one today for press. Okay, can you all do it? Do we have any solutions yet? Nobody's trying? Anyone would like to try? Okay, we go back to the question. This is our GSDT. GSDT equals cos t plus sin t. Okay, sine of pi equals 1. Okay, so what do? Again, we can use separation of variable by bringing t onto the other side. What do we get? If we bring t to the other side, what do we get? Hello? Look, I'm already talking to an empty room. Don't make me feel as if I'm talking to myself. Nobody wants to try? Come on, simple. Very simple.
Sin t minus cosine t.
First step that you do. Get
Oh, bring the dt to the right side.
yes, cos t plus sin t with respect to ed. And then you take integral on both sides. Okay? And then what you get on the left?
S
Equal
equals sin t
sin t
minus cosine t
minus cosine t. Okay.
plus
Plus c.
C.
Okay, but you know that sin pi is 1. Okay, so if you have 1 here, this is sin pi minus cos pi plus c. What is sin pi? What is sin pi?
Zero.
Eh? Sin pi is 0. Are you sure? What is pi? Sorry, not sin pi. S pi. Sorry.
S pi. Sorry.
S pi.
S pi is 1.
S pi
Yeah.
is 1. Okay, so S pi means you replace all the t with pi, right? What is sin pi? So we have
Zero.
here 1 equals, what is sin pi? Quick.
Sin pi is 0.
0. What is cos pi? What is cos pi?
-1.
Negative 1. Negative 1 or 1?
Because it's it's 1.
It's 1.
Times
Huh?
is a negative cos. Yeah.
Right. So what is C? What is your C?
Uh,
In this case, what is C? Hello?
this
Hmm? I'm still talking to myself.
that means C is 2.
C is 2.
Yes.
Everyone agrees?
Okay.
Does everyone agree? Yes, no, don't know. Don't care.
C0.
C is 0? Okay, we have C is 0, we have C is 2. Which one is the correct answer?
Because I see that cos pi is equal to 1,
Mm-hmm.
but in the equation we have is negative cosine, so it'll be negative 1.
Mm-hmm.
So it as pi is 1, so it'll be 1 equals to 0 minus 1 plus c. So the
Mm-hmm.
negative 1 brings to the left, it will be positive, adds to the 1, it will be 2 equals to c.
Yeah. When you bring the negative 1 to the other side, it becomes a positive 1. But what did we mess up? What did you mess up on the screen?
Cosine pi
Cosine.
equals to 1.
Yes. Okay? Cosine, right? It's
Yes.
negative 1. It is not. There should be another negative there. Right?
Yes.
Okay? All right?
Uh,
Everyone okay so far? So far, okay?
Yes, doctor.
Okay, great. Right. Okay. What we're going to do next is what is called the Euler method. Okay. Before we do that, I think we need a break. All right. Okay. We come back. It's now 1:50 according to my watch. So you come back in about 10 minutes. Is that all right? 10
Okay,
minutes for
doctor.
prayers. Is that enough?
Yes, doctor.
Okay. All right. So I'll see you in 10 minutes time.
In this video, we're going to talk about 9 different ways that you can make passive income. And for each of those, I'm going to talk about how hard it is to get started, how hard it is to make $100 a month from it, and how hard it is to maintain once you've created the thing in the first place. For me and my business, these 9 different sources generate around $27,000 per week these days with membership community. All right, nearly there. So idea number 8 for generating passive income is creating a business that sells goods or services and then automating or delegating aspects of that business so that the income that you generate from it is reasonably passive. This is the stuff that Tim Ferriss talks a lot about in the 4-Hour Workweek, where there are a lot of businesses that you could make where you're selling a good or selling a service, and then you can delegate, outsource, automate in intelligent ways to make the income passive. So again, using my friend Oliver as an example, on his YouTube channel, he talks about his $1 million Shopify store. He designs, manufactures, and sells these really cool vegan leather kind of desk accessories and bags and mouse pads and that kind of stuff. And this was loads of work in setting up, but now he's got a team of 3 other people that manage the business. And so he spends proportionally less of his time running that business. And so it's sort of passive income for him, even though these days he still does spend around 10 hours a week maintaining things. Equally, if you're going down the service route, I've got a friend who runs Instagram and Facebook ads marketing agency, where he has clients who pay him I think a few $100s per month to manage their Facebook and Instagram ads. And for him, it's like a small amount of work initially to set up the Facebook and Instagram ads, but then it's sort of automated and he's got a team around it and he's using things like Zapier to automate aspects of that business so that each month he has to do a very small amount of actual work to keep it ticking along. So these are different ways of generating passive income from a kind of goods or service-based business, but it's quite hard to get started with this stuff. To get started, we're gonna give this a 4 out of 5 star rating because again, you need to create a business and it's quite hard to make a business that genuinely provides value. Equally, we're gonna give it a 4 out of 5 star rating for making $100 a month in revenue because again, you have to be able to provide value. And providing value is hard. Like, it's not as easy as making an account on a stocks platform and just putting some money in. You actually have to give value to people, which is kind of hard. But the nice thing is once you get started, like with anything, maintenance is a little bit easier. So we're gonna give that a 3 out of 5 star rating. Finally, idea number 9 for generating passive income is to build an app or a website or some kind of software product that you can offer either as a one-off or more likely these days as a subscription service. And there's a whole category of this called SaaS, software as a service. Now, if you look at the website indiehackers.com, there are like literally hundreds of examples of people who have built software businesses that are making passive income, and they share their revenue numbers and they tell you how they got started and they give you their tips. In fact, I was recently interviewed on an episode of the Indie Hackers podcast, which is really cool because I've been listening to it for years and like been following the website for years. And I was interviewed around the concept of starting an online course like the Part-Time YouTuber Academy. Now, I've had a bit of personal experience with this. So when I was at university, I made a website called BMAT Ninja and UK Cat Ninja. So software as a service, it was a question bank for medical applicants applying to medical school to help them do well in the admissions tests. And this was something that me and my brother coded completely from scratch. He and I both know how to code. We learned when we were young. And so we worked over the summer of 2015 to make these things happen. I think in year 1, we made about $10,000. And in year 5 last year, it was around $25,000 from BMAT Ninja. So, you know, it's pretty good money, but it was a lot of work to set these things up. And so in
Super Idol 的笑容都没你的甜，8月正午的阳光都没你耀眼，热爱105度的你，滴滴青春的川流水。Super Idol 的笑容都没你的甜，8月正。Super Idol 的笑容都没你的甜，8月正午的阳光都没你耀眼，热爱105度的你，滴滴青春的蒸馏水。Super Idol 的笑容都没你的甜，8月正午的阳光都没你耀眼，热爱105度的你。Super Idol 的笑容都。
Super Idol 的笑容都没你的甜，大约正午的阳。
Right on path.
Why is it so close?
Bloodhound on me.
You are the Apex champions.
The fuck? What the fuck happened to my arm? Oh my god, that reminds me.
Can't believe this.
No.
I can't
oh my
fucking
god,
believe
my
this.
screens are all black.
You all can't sign your attendance. Okay, let me see if I can do something. Okay, can you all try again? Try again to sign your attendance, please, class. Hello, are you all back? Now can, all right. Okay, what we're going to do next is what is called the Euler method. Okay, it's spelled E-U-L-E-R, but it's pronounced as Euler. Okay, so what is the Euler method? Okay, there are a lot more examples in your notes. Look through them. Okay, now we know that an ODE is in the form of dy dx, which is equal to fxy, right? Okay, if you look at Taylor's theorem, you all familiar with Taylor's theorem by now? Taylor's expansion. Look at this. Now, don't tell me you are not familiar with it because we've used it over and over again. Okay, look at this part here. Can you see that? Can you all see that?
Yes, doctor.
Okay, right. Now, when do we stop with Taylor's expansion? It depends on how we want to go on, right? If it's in order of h, order of h squared, order of h cubed, order of h4, and so on. Okay, now normally you wouldn't want in order of h, that would be far too inaccurate. Maybe in order of h squared. Okay, if it's in order of h squared, where do we stop? Where is h squared? On the right side of the equation.
Y to the y double bar.
Yeah, it's the third term on the right hand side of the equation, right? This part here. Okay, now if we remove all this, that is your error, isn't it? Agreed? If we just take until here, all this will become your error. Okay? Do you all agree?
Yes, doctor.
Now, since h is a small number, okay, the error is dominated by h squared. Now, if h is a big number, of course, it will be dominated by the higher order. But h is between 0 and 1. So because h is between 0 and 1, it is dominated by h squared. But if we stop here, then it is dominated by h cubed, and so on. Okay, that's what we call order of h squared, or order of h cubed, or order of h4. Now, the Euler's method is based on this. Okay, the Euler's method is based on the Taylor's expansion for fx, where h is your step size. Okay, so we stop at, okay, I'm going to the board now. I don't know if you can see the board. Tell me if you can't see the board.
Okay, doctor.
You can?
Yes, doctor. We can
Okay.
see.
What was it? F of x plus h is f of x plus h f of x, f prime x, plus h squared f double bar x over 2 factorial, and so on. Now, this is our error term, which is in the order of h squared because it's dominated by h. So what this means is that with the Euler method, we are only looking at this part here. Okay? And as I have earlier mentioned, the Euler's method is also called the Runge-Kutta first order method. Okay. If we say that yx n is f of xn. Agreed? Hello?
Yes, doctor.
Okay. Then y of xn plus h will be yn plus 1. If y of if h is the step size, or if we say that y of x naught equals to f of x naught, and if we say that x plus h is the next step, that means you have x plus h, okay, which is the next one. All right, so this will be x1, and then you have another h, x2, and so on. Okay, where h is the step size. So y of xn plus h is y of n plus 1, or y of x naught plus h will be y1. Do you all agree? Yes?
Yes, doctor.
Okay, looking at this and this, what the Rangakata method says is that yn plus 1 can be written as yn plus h of y prime x n, or y1 is y naught plus h y prime x naught, or f of x1 is f of x naught plus h f prime x naught. Okay? Do you all agree with all that I've written on the board?
Yes, doctor.
Okay, and as I say, this is how we would solve a numerical ODE using what is known as the Euler's method. Okay, so how do we use the formula? Okay, now we've got all that written on the board. Let's look at an example. We want y2, we plot it in, right? Using the formula we have. What is y2? Y2 will be y1 plus h y prime x1, which is what we have. Of course, your f can be a function of x and y as well. Okay? So far, so good? Hello? Right. Now, let's look at an example. Okay, this is the general one, which we've done. Okay, and this is what it would look like graphically. Okay, let yx be the solution to the following initial value problem. dy dx equals sine y minus 3x. Y naught is 1. Okay, use Euler's method to estimate y of 0.1, y of 0.2, and y of 0.3. So how do we do this? How do we do this? Okay, we've got the formula. What is the formula? The general formula is this one here. Okay, right? What is our equation? dy dx equals sine y minus 3x. Y naught is 1. Okay. How do we go about it? So y naught is 1. We want y of 0.1. Y of 0.1 will be y naught plus 0.1, right? So what is our h here? What is our h?
0.1.
0.1.
H is 0.1. So we want y of 0.1, and we know that it is y naught plus 0.1. So we say that y of 0.1 will be, plotting this in, it would be y naught plus h y prime x naught. What is x naught? What is x naught? What does y naught means? It is y of, hello? Y of?
Y of
Y of? Would it be easier if I use f instead of y? Nobody's saying anything. Okay. What is y naught? Y of? What does this mean? When you look at this, what does it mean to you?
You substitute like you put 0 in place of
A
x.
variable here. What variable would be inside here?
X.
Yes, x. Yx, right? So, and we know that this is actually y naught. So this is y of x naught. Agree? Yes or no? Hello?
Yes, Doctor.
Yes. So what is y? We are going to call this y1, okay? So what is y of 0.1? It is y naught plus h of y prime x naught. Okay, y naught we know is being given 1. H we know. What is h? We discovered earlier. Where was h? Okay, this is h. What's h? Hello?
0.1.
0.1. So now what is y prime of x naught?
Y.
What is y prime? Sine of? What is y prime? What is this equal to? Can you all see what I'm writing?
Yes.
Hello? What is this?
Y prime would be sine y minus 3.
Sine y minus
3.
3x.
3x.
I'm writing it side by side. Can't you see? Can't you see this? Right? Okay. So what is sine y minus 3x in this particular case? Sine of what? What is y? We want to find what? X naught, right?
Yeah.
Okay, so sine of what? Okay, you know it's x naught, so 3x naught. What is this here? What is y here?
X naught.
What is y? Sine y. Why are you changing y to x naught?
Because we substituting x naught, we are using y x naught.
Yes, okay, so you're substituting x naught. So this becomes sine of whatever minus 3x naught. Yes, but what is this?
This would also be no,
This would also be?
x naught.
Why are you changing the variable?
Oh no,
So what should it be? Come on, think.
why not?
Yes, why not? Okay, so what is y naught? It is sine of 1, right? Remember, y naught is given as, where was it? Y naught is 1. Y naught is 1. So sine of 1 minus, what is x naught?
0.
0. So sine 1 minus 0. So what is sine 1 minus 0? We take sine in radian. Can you all give me what y1 is? I've given you, I've guided you till that part. Give me now what y of 0.1 is.
We are taking the answer in radians, right?
Yes, everything is in radians. What do you get? 0.841. Is that what
Yeah.
everyone gets?
Yes, doctor.
Yeah.
Yes, doctor.
Everyone agrees? Everyone agrees?
Yes, doctor. 0.841.
Pardon? I can't hear you.
I'm saying yes, yes. That's the
Yes. So the answer is 0.841. Has anyone else got a different answer? Has anyone else got a different answer? Everyone's got the same answer? Come on, come on. So everyone has got 0.841 as the answer. Are you answering the question?
no, just for the sine one.
Ah, for which part?
Sine one.
For sine y, okay. For this part here. For this part here, right? Right? Okay, 0.1 into 0.841. Okay, now what is the answer?
Doctor, can you like side the chair because it's like blocking the bottom line?
Move the chair, okay.
Thank you. $1.0841.
1.0841. Everyone agrees? Yes, 1.084. If you are looking at 3 decimal places, it would be 1.084. Yes. Now, can you find y 0.2? The next one? Y of 0.2. it would be the next step, right? It would be y2 because the step size is 0.1. Can you do that on your own? 0.2, just give me the answer. Come, try. Same way, all you need to do is plot in, substitute the right values into your equation. You're still working with yn plus 1 is the same as yn plus hy. Okay, I'll write the equation. You're still working with this yn plus 1, yeah? Now, remember, we don't have a subscript here, yeah? Okay, we're still working with this. So what is y of 0.2 now? So your yn, if it's y of 0.2, which is y2, I mentioned earlier that we'll call this y2, then this should be y1, h of y prime 1. Okay? And what do you get? Meaning that your y of 0.2 is the same as y of 0.1, which plus h y prime 0.1. Okay, y of 0.1 was the value you obtained earlier. H, we all know what it is. What is y prime of 0.1? Okay, I give you 2 minutes to do this. Come on, I've put all the essential. Okay, good. There's an answer here already. Has anyone else got a different answer? Any different answers? No? So we all agree that that is our value. Okay, now would you be able to do y of 0.3 on your own and we move on to the next topic? Okay, our next topic should be, what should it be? Euler's method we've done. Okay, Runge-Kutta method. Now, I'm not going to show you how to obtain the Runge-Kutta method because it involves partial derivatives. But suffice to say that the Runge-Kutta method would be using the Taylor's expansion that we have earlier. Remember the Taylor's expansion? Where is our Taylor's expansion? Okay, can you see the Taylor's expansion?
Yes, doctor.
Okay, and we will take it up till H4. Okay, so the Runge-Kutta method is actually, it would have an error of order h to the power of 5. All right, and the Runge-Kutta method simplified. Okay, it is something that you will just have to work with formula, because as I say, I'm not showing you how to derive the formula, but be thankful that your exam is open book. Okay. This is your Runge-Kutta method. Okay. Runge-Kutta method is written as y to the n plus k1 over 6 plus k2 over 3 plus k3 over 3 plus k4 over 6. Now, if you take out the 1 over 6, you can say that yn plus 1 over 6, open bracket, k1 plus 2k2 plus 2k3 plus k4, close bracket. We ignore the order of h to the 5. So the Runge-Kutta method is written down as this. Okay, can you see that?
Yes, doctor.
This will be your Runge-Kutta method. Well, they are both Runge-Kutta method, this and this. Okay, so now what is K? What is K1, K2, K3, and K4? Right. K1 is defined as H of f, x, and yn, while K2 is defined as f of xn plus h over 2. That means the step size, okay? The xn plus half the step size, and yn plus k1 over 2. What is k1 over 2? This one. Okay, and K3 is xn plus h over 2, yn plus K2 over 3. Over 2. And K4 is f of xn plus h, yn plus K3. Okay? Like I said, it's a matter of remembering the formula unless you want to work it out. But as you are sitting for open book tests, you don't have to worry about remembering formulas. Okay? So let's look at an example. Okay. Let y be the solution to the following initial problem. dy dt equals y minus t squared plus 1. Y of 0 is 0.5. Use the Runge-Kutta method with step size 0.5 to estimate y of 0.5. That means you only have to do it once because the step size is 0.5. Okay, can you all do it? Just use the formula. Okay, I'll show you the formula. Okay, so, or maybe you need the case as well. Okay. Can we get it all in one page? Yes, we can. Okay, you've got your formula here. And the question is here. Okay, if we make it smaller, maybe we can get everything together. There you go. All right, can you all try this? Okay. What would be the first thing we do? Is everyone working or you just staring into space?
Trying.
Trying. Okay, good. Okay. Any answers yet? No? No clue on how to go on? Can you at least start? Okay, my laptop is running out of battery. I need to run and get my charger. By the time I come back, can I have a solution? No answer. Am I talking to the class or am I just talking to myself?
We are trying the question.
Okay, you try. I'll go get my charger.
Okay, doctor.
Okay. Since you are the first thing you would have to do would be to find K1. And what is K1? K1 as defined is h of fxn yn. In this case, it would be h of x0 y0. Okay, what is h? What is h?
0.5.
0.5. What is f of x0 y0? Actually, it should not be x, right? What should it be? Our K1, it should be t, yes. F of t0 y0. So there are mistakes in the notes, you adjust it accordingly. Okay, now if you can't detect this mistake, I'm very sorry for you. All right, you should be able to detect this mistake. Why? We are dealing with functions of y and t here. Okay, so what is h of t0 y0? H of t0 y0. H we know is 0.5, okay? So what is h of t0 y0?
0.75.
0.75. How
No,
did that?
the whole thing. K1.
Okay, let's do it then. Okay, you read out to me the question. This one you all agree? What I've written?
Yes, doctor.
What is that? That is the Rangda Kata method, right?
Yes.
Okay. What is K1? K1 is HF of, well, this method, right? X of. Since this is a general formula, it doesn't matter whether you put X or Y. So it should be X of N, Yn, Xn, right? What is K2? X first, then Y. What is K2?
HF.
F of X n plus H over 2.
Y.
Then K.
K1 over 2.
Yn plus K1.
K1 over 2.
What is K3? H of Xn plus H over 2. Yn plus K2 over 2. Right? And what is K4? Hf of Xn plus H. Yn plus
K3. K3.
Okay, now H does not vary, but K varies. H does not vary because H is the step size. Okay, H is the step size. For the first K, we're just taking X naught, Y naught if we are starting from naught. For the second K, the H is divided by 2. For the third K, the H is divided by 3. And for the fourth K, the H is on its own. It's just H. While K1 is taken from here, and K1 over 2. And for K3, it is K2 over 2. What is K2? K2 will be this one. And for the final one, K4, it is just K3. So can you see the pattern there? Okay, what is our question? dy dt equals y minus
t squared plus 1.
And y of naught equals to
0.5.
And we have to find y of 0.5, right? Y of 0.5 will be y naught plus 0.5, right? Sorry, y of naught over 0.5. In this case, this is our h. Okay, so what is K1? K1 will be h of x naught, y naught. Okay, and in this particular case, it is h of f of t naught, y naught, right? What is t naught? H is 0.5. What is t naught? What is T naught? What is T naught? What is T naught?
0.
0. Okay. What is Y naught?
0.5.
0.5. So you have the function of 0 and 0.5, right? So what is f? F is your dy dx. Remember, dy, or in this particular case, dy dt. So what is f of 0 and 0.5? So this will be your 0.5 and this is your 0. So what do you get here? Okay,
1.5.
0.5 into this is 0.5 minus 0 plus 1. What is that?
1.5.
1.5. So what is K1?
0.75.
0.75. Everyone agrees? Yes? What is K2? Coming back here, it would be 0.5 f of x naught plus 0.5 over 2 y naught plus K1. What is K1? 0.75 over 2. Okay, which means it's 0.5 f of, what is 0.5 over 2? 0.25, right? What is x naught? X naught is so 0.25, y naught is 0.5. What is 0.75 over 2? 0.375. Agreed? Is that right? Hello?
Yes, 0.375.
0.875. Okay. So what is this value here? You put it in your equation here. Y minus t squared plus 1. What is y? 0.875. What is t? 0.25 square root plus 1. And what do you get? Hello? What do you get? Come, I've given you this much. What do you get? What do you get?
0.9 0.9063.
0.906. Yeah? 0.906. Okay. Okay, what is K3? 0.5 into f of x. Sorry, this should. Yeah, okay. 0.25 and K2 over 3. This 1 over 2 plus y, 0.5. So what do you get? What do you get? .96 will be 453. Y naught is 0.5. 0.953. Everyone agrees? Yes? Yes? Yes or not?
Yes, yes, doctor.
Okay, and what do you get? What do you get? Okay, somebody has put the complete answer here. Do you all agree? Can you see the in the message?
Yes, doctor.
Who does not agree? Do we have a different answer if you've been doing it? Do you have a different answer? Yes, no, don't care.
No, doctor.
Any answers which are different? Okay, so everyone agrees? All right, it's not difficult, it's just a little bit tedious. Okay, all right, so can we move on? There are other examples which you can do. And you've got enough questions in your tutorial as well as in your review paper, I believe. Can we move on?
Yes, doctor.
Okay, the next topic we're going to do will be second order differential equation. Okay, second order differential equation. Okay, answers are all there, okay? So you work it out yourself. Second order differential equation would be in a particular manner. Okay, but I'm just going quickly into an example. All right, we are going to do this one. Y to the power of 2 minus y equals to 0. Y to the power of 2 minus y equals 0. Okay, we want, this is a second order differential equation. Now we want to solve for this. Okay, now we can do it intuitively. And if we do it intuitively, we will get one solution, cx to the power of e. C e to the power of x. That is one solution. But there should be one more solution. But I'm not going to go through the intuitive method. I will just, there is some mistake in the equation, okay? There is some mistake in the notes. What I'm just going to go through with you is looking at characteristic polynomial. Okay, now if you look at this, okay? Now if we say that R is equal to y prime, y, R squared is equal to y2 prime. R is y prime. Okay, we say that. And then, of course, r to the power 0 is y. Okay? Then our y squared minus y can be written as r squared minus 1 equals to 0. Do you all agree? Yes or no?
Yes.
Yes or no? Okay. Now this is called the characteristic polynomial. That means we replace the differential equation with a variable. If it's second order, then the variable is in power of 2. If it is first order, then the variable is in power of 1. If it's y, in this case, we replace it with a constant. Okay, now looking at this, we can look at b squared minus 4ac. Okay, do you all know what this is? Roots of equation? Hello?
Yes, that.
Roots of equation? Okay, if b squared minus 4ac is greater than 0, b squared minus 4ac is equal to 0, b squared minus 4ac is less than 0. What can you tell me?
If it's more than 0, then it's like it's high, order of 2 or more.
No.
Order of 2.
And b squared minus, you all know what your b's, your a's, your c's are?
Yes.
It is ar squared plus br plus c, okay? Equation is in this form. Okay? Right? Right? Class?
Yes, doctor.
Okay. Now, when b squared minus 4ac is greater than 0, the roots are distinct. What does that mean? You have two distinct roots. What does that mean? If your roots are r, then r1, which is one root, and r2, they are not the same. Okay, they're distinct. When b squared minus 4ac is equal to 0, what can you say?
There is only one root.
Equal roots. Okay, the two roots are equal. When b squared minus 4ac is less than 0,
There are no roots.
There are no real roots.
there are no real roots, but you've gone beyond that. You're no longer saying there are no real roots. You know there are roots, but the roots are, what are the roots? What about the roots? Come. When b squared minus 4ac is less than 0, the roots are? Nobody's giving me the right answer. No? What happens when b squared minus 4ac is less than 0? Two complex roots, yes. The roots are complex, okay? And what's the difference between one root and the other? It is the conjugate. Okay, so if one root is a plus ib, the other root would be a minus ib, right? They're conjugate, two complex conjugate roots. That's right. Okay, so you can actually solve this equation by looking at the characteristic polynomial. Okay, let's look at one example. Okay, y squared minus 5y prime plus 4y. Okay, so we have y squared minus 5y prime plus 4y equals to 0. Is that our equation? No, plus. Plus. Okay, so what is your roots? What is our characteristic polynomial? Our characteristic polynomial will be r squared plus 5r plus 4 equals 0. Okay, so if we look at, well, actually we can easily factorize this, right? We get r plus 1, r plus 4, right? We don't even need to look at what the roots, the characteristic of the roots. So we know that r equals to minus 1, r equals to minus 4. So the solution is actually y1 is e ce to the power minus x, and y2 is actually ce to the power minus 4x. That is your solution. Okay? All right. Oh, your C's here are not necessarily the same. Okay, so you call it C1, C2. Now, in order for you to solve for C1 and C2, we need boundaries. So the boundary value problem will help you solve for the roots. For not the roots, for the C1s and C2. Okay, so an example of that would be, so there are other examples to repeated roots and so on. You can do that on your own. Okay, and of course the two complex conjugate roots. Now let's look at boundary value problem. And that's the summary. Okay, the boundary value problem will help you solve for your C1 and C2. Okay, we have d2y dx squared equals y. d2y dx squared minus y equals 0. d2y dx squared minus y equals 0. So if you solve this, what is the characteristic polynomial? It will be r squared minus 1 equals 0, right? What is r? This can be easily solved. R will be plus or minus of square root of 1, which is plus or minus of 1. So the solution to this will be C1e minus x, and solution 2 is C1e x. Okay, these are the two solutions of your second order ODE. Now, how do we solve for C1 and C2? We have boundary values. Y naught is 0 and y naught is 1. Okay, using the values of y naught equals to 0 and y naught equals to 1, we can solve for C. When y naught equals to 0, okay. Y naught equals to 0 means that C1e to the power minus x equals to 0 when this is 0, right? So what is C1? What is C1? Okay, y naught equals to 0, meaning that you plot this in. If this is 0, you'll have 0 equals C1 e to the power of 0. Doesn't matter if positive or negative. So what is this? What is e to the power of 0?
1.
1.
1. So we have C1 plus C2 equals to 0, meaning that C1 equals to minus C2, right? Agree?
Yes, doctor.
Yes, doctor.
So the other boundary given is y1 equals to what? y1 equals to 1. Okay, when y1 is equal to 1, what we'll get here is 1 equals to C1 e to the power of 1 plus C2 e to the power of 1. What is, it doesn't matter what e to the power of minus 1, you can leave your answer in the form of e. So what is C1? But we know that C1 is equal to minus C2, so we can put this as what? C2 e to the power of minus 1 plus C2 e to the power of 1, right? Meaning that C2 e to the power of 1 minus e to the power of minus 1 is equal to 1. Right? So what is C2? Solving for C2, what do you get? What do you get? It doesn't matter if you solve for C1 or you solve for C2. Okay? So what do you get for C2? What do you get for C2? What is C2? C2. 1 over, you want C2, right? Class, are you still with me?
1 over e.
1 over e to the power of 1
minus e minus 1.
Minus 1. Okay? So with the boundary value problems, you can find an exact solution. Okay? And that is the end. There's another example which you can do on your own. That is the end of ODE. Now I want to go quickly through PDE. It's already 3:13. Now with PDE, the room is really hot here. PDE, what is it that we do? Okay, PDE is when you have partial derivatives. Okay, an example given is t to the power of 5 you have t to the power of 5 s to the power of 9 plus 2t plus s to the power of 4. And this is a function in terms of s and t. Okay, if you're looking at t to the power of 5, s to the power of 9, 2t, s to the power of 4. Okay, if you're looking at partial derivatives, you can take delta u with respect to delta s, and you can also take delta u with respect to delta t. Okay, if you're taking with respect to delta S first, you differentiate with respect to S. When you're differentiating with respect to one variable, the other variable acts like a coefficient. Okay, so looking at this equation, let's differentiate with respect to S. What do you get here? Somebody call out loud. Say out loud, quick.
5t to the power of 4
We are differentiating with respect to S.
to s. Oh, 9t to the power of 5.
9t to the power of 5.
S to the power of 8.
S to the power of 8. What about this?
Plus 4s to the power of 3.
As 4s to the power of 3. Now remember I said when you are differentiating with respect to one variable, the other variable acts in this case as a coefficient, in this case as a constant. Okay, it's just like a number. Do you understand? Okay, so that's how you get your 9t. You're only differentiating your s part. So this becomes 9s to, sorry, you're only differentiating your s part. So this becomes 9s to the power of 8, which is what we have. The t remains, but this acts as a coefficient, as a constant, so it disappears. Now what happens when you differentiate with respect to t? Same equation.
5t4
5t to the power of 4
s power 9
x to the power of 9 plus
2.
2. Okay? Now, that is how you would differentiate partially. So these are your partial derivatives. Now, okay, you can find other partial derivatives. We are going to quickly look at higher order partial derivatives. Okay, that means you can differentiate twice, you can differentiate 3 times. And we can go on and on. We can have mixed derivative. What is mixed derivative? That means you differentiate once with respect to x, and then the second time you differentiate with respect to y. Okay? All right. Now you can also use the chain rule for partial derivatives. df dt is the same as df dx, dx dt, plus df dy, dy dt. Okay, so that's your chain rule. Okay, examples on partial derivatives, you can look on your own. I just want to show you the equation. Okay, so this is how a partial, a PDE or a partial differential equation would look like, where your x1, x2, x3s and until xn would be your independent variable. PDE with 2 variables can be written as this. Okay? Now, so you actually use subscript for to denote that they are partial derivatives. Okay, and this is how a first order PDE will look like, and then next you have a second order PDE, and the second order PDE is actually a Poisson equation. Now again, your second order PDE can be classified based on the roots. Okay, and if b squared minus 4ac is greater than 0, you have 2 characteristics and you get a hyperbolic. If it is equal to 0, you get 1 characteristic and this is called a parabolic, while if it is less than 0, no characteristic, and it's called an elliptic. Okay, so this is the canonical form, and the general solution. Don't worry too much about it. Examples are given, but don't worry too much about it because you are not majoring in mathematics. You don't have to do too much of PDE, partial derivatives. Okay, so this is the classification, and that's your characteristic equation. This is the type and the number of characteristics and the canonical form of your equation. Okay. Simple, we are going to solve simple PDE. How do you solve them? You have d2z dx dy equals to 4x squared y. In its simplest form, we do separation of variables. Okay, so how? How do we do separation of variables? The same way you do separation of variables for, what do you call it? ODE. Okay, first we integrate with respect to dx, and then we integrate with respect to dy. Okay, when you integrate this with respect to dx, okay, what do you get? It's the x that will, the powers of x which would change. So this becomes 4x cubed, but the y will remain. But don't forget, you will have a function of y, because when you differentiate a function of y partially, it would be gone, right? The same thing when you integrate with respect to dy. You will have then a function of x, because once it's differentiated partially, it will be gone. Do you understand what I'm saying? Yes or no? Yes or no?
Doctor, for the hy is from the previous one, right?
Which one?
The hy is from the previous integration, right? When we integrated with
This
respect to
should
x.
be this one. This one
Yeah.
here. Mm.
Okay. Understood.
The function of y becomes a h of y. Do you know why? Do you know why?
Because it
you
also
are
got integrated.
yeah, you're integrating it further. So it's no longer the same function.
Yes.
All right?
Yes.
Okay, so this is what this is all about. Now this form here is called the general solution, and you can determine hy and gx with respect to your IVP or BVP. Okay, you can also do separation of variables. Sorry, just now wasn't separation of variables. It was actually a partial derivative. Now, using separation of variables, it would be the same way that you did earlier. Okay, you bring one to one side and the other to the other side. All right? Okay, now the separation of variables say that your solution should be in this form. So looking at the derivative, you will get a function of gt and a function of phi x. A function of x and a function of gt. So just look through it quickly and don't worry too much about it. Okay, I think that's it. That you can also use finite difference method, but looking at how you all solve finite difference in the exam, I don't think this is a strong point for you. Okay, so this is actually the end of our the formal part of the course. Do you have any questions? And that is your syllabus actually. Do you have any questions? Any questions?
So this is like the complete thing which will be getting in the final exam, right?
Well, your final exams will be based on lecture 1 until lecture, I don't know what number today's lecture is. Okay?
And for the test for next week?
Up till today's work.
Okay.
But after the test, you have one more lecture with me, and that will be reviewing either the test and some of the review papers, or if you have any questions you want to ask me. I will also go through the whole syllabus quickly. Okay, what is important for today's topic? Usually, if you look at the past year papers, what normally is stressed on is more of the ODE than the PDE. All right? Maybe there might be some PDE questions, but these are normally the simpler ones. Okay, any questions? Have you all looked at your results? You should know roughly what your average should be. If you get A, of course your average will be A. If you get A minus A, chances are it's either A or A minus, depending on how strong the A was and how weak the A minus was. If it is a B, C, A, it could be a B, it could be a C. Or it could even be a B plus or a C, an A minus, depending again on which, because it's a range of values. Okay, but bear in mind what your average is so that you know what you need to get in order to achieve the results that you want. I will put up your coursework results after test 4. Okay, any questions? Okay, in all the topics that we've done, which is the most difficult? Are they all easy? Amir, you are repeating what has been asked. What are the topics of test 4? Most difficult is differentiation. Why is differentiation difficult? Okay. Right. Why is differentiation difficult? Which part of differentiation? Numerical differentiation. Okay. What are the topics we did under numerical differentiation? It is the what do you call it? Finite methods, isn't it? Is it the finite methods? All of it. Okay, let's see. I don't recall what we did in differentiation anymore. Forward difference, backward difference, and central difference. This actually is the easiest in your course. It's just a matter of using the formula, feeding it into the formula and finding the formula based on simple arithmetic. Okay, in that case, you need to practice, and I've provided one paper which is dedicated to finite methods, finite differences. Okay, so please practice. Is there any of you who have not submitted your assignment? anyone in this class who have not submitted assignment? Because once I put up the results, you can't submit anymore. At this stage, I am still allowing those who have not submitted to submit. I think I put up 2 names. 2 people did not submit. I can't remember offhand who they are. All of you here, how many students are there here today? How many of you today? Let me see your attendance. Only 41 students. There's supposed to be 48 of you. Okay. I don't remember where it was that I put up, but I know 2 people did not submit assignment. But this is your last chance. If you don't submit after I put up the results, then I will not accept anymore. Okay, now if you do have problems with whatever, differentiation, integration, factorization, LU factorization, LU decomposition, just send me a message and I will help you. Some of you have been contacting me and I have not ignored anyone so far. Has there been anyone that I've ignored? I think I've answered your messages no matter what time you send me the messages. If I'm too tired to go through the question, then I'll say I'll tell you tomorrow, or I'll go through with you tomorrow. But I have always responded to whoever contacted me. So if you do have problems, please let me know. Some of you have done quite well in your in your tests and your assignment. Let me see if I can find it. Okay, what I can see is that let me see if I can copy the graph. All right, can you all see the graph?
No, doctor.
Now?
Okay, yes.
Okay, this is overall, excluding test 4, of course. This is overall. What this means is that 1 is actually A, 2 is actually A minus, 3 is so on and so forth. So 10 is actually F. Okay, if you can see more of you, there are about 18 of you in A. I think you all know who you are. So if you fall within this category, well, within the 4 categories, so this is A minus, B plus, B, and C plus. Okay, I have not given any A plus in this course for coursework, but when it is submitted into the final system, you may get A plus. But for assessment purposes, I did not give anyone A plus. Do you understand what I'm saying?
Yes, doctor.
Okay, because I don't want you to be overconfident. So quite a number of you, I think, well, slightly less than half the class has got A as an average for all that you've done. Okay, so the rest of you, A minus, B plus, B, and C plus. Now, I did say if you have got a C minus, you can contact me and I'll try and give you a replacement test. But I have not named the day of the replacement test yet. One person has, where can I find test 2 results? Where is test 2 results, class?
In the spectrum.
In spectrum. Let me see. Test 2 results. Can you all see my spectrum page? Is it visible at the moment? Spectrum?
Yes, doctor. Yes,
Yeah?
doctor. Yes.
Okay. Is it in the announcement?
I think it is in like the main spectrum. The one in the announcement is test 3.
Okay, okay. There you go. Oh no, that's the test.
Doctor, I sent the link inside the chat room.
Oh, you've sent inside the chat. Where is? I can't seem to find it. It's there somewhere. It's just that I can't seem to. That's the test. So the result should be, maybe it's in the announcement. There you go. Test 2 results. Okay. That's test 2 results. If you haven't seen, you can go and see now. All the results are up. Okay, any questions? Any questions? Okay, there was a problem with the first results I put up. Not because the marks were wrong, but because the conversion from the marks to the grade, there was a slight mistake in the conversion. But don't worry, your marks will stay, your marks are not affected. It's just that the conversion, what do you call it, the formula used to convert the marks to grade was wrong. Okay? All right, any questions? Any questions? Any questions with the tutorials or even with the review papers? How many review papers have I given? Does anyone know? Okay, let's see. Review papers.
Four, doctor. You are given 4.
Yeah, there's paper 1, paper 2, paper 3, and paper 4. Okay. Now this should be more than enough to help you prepare your for your test and for your final exam. All right. Any questions so far? Any questions? If there are no questions, I will end the class here. Okay. And don't forget you have a test. I will not be coming into the faculty from tomorrow onwards because we've been disallowed to enter the faculty, to enter the university. It's going to be a total lockdown, as I've mentioned. So if you do have any questions, just send me a message. Somebody's sending me WhatsApp. I'm looking at the laptop at the moment. Okay, you want me to look at the WhatsApp? Somebody's asking me if you have roughly unofficially marked the assignment. Yes, I have. I have marked the assignment. Haven't I put up the results? I think with the assignment, there should be no problem. Assignment. Haven't I put up the assignment results yet? Yes or no?
No, doctor. We cannot.
No, doctor.
See any. No, doctor.
Okay, now, unless you don't follow instructions. Okay, most of you got A's and B's. There is one F. I think 2 F's. I think those are the ones who did not submit, and there are about 10 C's. Now, the C's are those who did not follow instruction. Yeah, there are 10 C's. The C's are the people who did not follow instruction. Now, what does that mean? What does it mean? You did not follow instruction. Okay, I will put up the results of the assignment soon. What does it mean you did not follow instructions? You are supposed to put up your quotes as well as your output. Some of you just give me quotes expecting me to run your quotes. Some of you give me quotes. Well, you know, when I'm looking at your work and I'm trying to mark, it should be in a writable form. Now, if you give me in Python, I will have to run it in Python. Okay? Now, if you don't give me output, I have to run it in Python again. So, if you don't follow instructions, your marks are cut. The best thing for you to do is to follow instructions. The same with your assessment. Every assessment, every test that you take for, there are instructions. It says to submit your questions in a certain format. Some of you have been giving me in Word format. Some of you have been giving me in image format. Okay, so please follow instructions. You have to learn to follow instructions. Now, if you write a computer program, what is the first thing you learn about programming? How would you like it if the computer that you are working with do not obey your instructions? The concept of programming is for you to give instructions, step-by-step instructions in a clear way that your computer will carry out, right? Okay? You are used to giving instructions. You must also be used to obeying instructions. If you don't follow your instructions, then you are not working towards logical programming. Your computer would follow your instructions as well. Okay, so please be logical and please follow instructions. All right, any more questions? I can't remember, Tarin. It depends on how difficult it is to read your notes, to read your assignment, and to look at the results. Okay, some of you did not submit plots when the question is obviously plot. Some of you do not submit answers. Some of you just give codes without answers. All right? But rest assured, your assignment is only 10%. Okay? But everything adds up. All right, any more questions? I don't remember offhand. I will have to look at the assignment and check again. Okay? Right, any other questions? No? If there are no questions, please don't forget to sit for the test next week and come back for the review the following week and your final assessment. There is only one final assessment, yeah, not two. Although initially we said we'll have two final assessment, there's only one final assessment. Okay? Okay, so if there are no questions, all the best, and please stay at home, take care of yourself. I know most of you have not been vaccinated because you are probably in the third phase. So please stay at home and look after yourself. Follow the SOP if you do go out to get food or for whatever reason. Don't share anything with friends. Okay. If there's nothing else, I'll leave you now. Goodbye.
Okay. Thank you, Doctor.